Today we're on pages 150 and 151 of our textbook, and you want to have your calculator. Summation notation. Much of our work in this unit will concern adding the terms of a sequence. To specify this addition, we introduce a new notation known as summation or sigma notation that will represent these sums. So summation, otherwise known as sigma notation. We have this symbol here, which is the Greek letter sigma, and it stands for sum or summation. So we have the summation of f of I going from A to n. So we start with A, whatever that is, the number 4 or 7 or 1, and then we increase by increments of 1. So I is called the index variable, which starts at the value of A and ends at the value of n. Moves by unit increments, so it increases by 1 each time. Evaluate each of the following sums. So this is the sum of 2i, I starting at 3 and going to 5. So we are going to create a table. So here's I and 2i. So we start with 3, substitute 3 in for I, 2 times 3 is 6. Then we increase 3 by 1, so 4, 2 times 4, 8, and increase by 1 again, 5, 2 times 5 is 10. And now we add these. So this is 6 plus 8 plus 10, which is equal to 24. B, the sum of k squared, k starting at -1 and going to 3. Make our table. K is starting at -1, and it's increasing by 1 each time, so -1, 0, 1, 2, and we stop when k is 3. -1 squared is 1, 0 squared, 0, 1 squared, 1, 2 squared, 4, and 3 squared, 9. And then we add these up, 1 plus 4, 1 plus 0, plus 1 plus 4 plus 9. Our answer is, I'll write it above, 15. Now, the written form, the addition, this is called the series, and this is known as the sum. C, we have the summation of 3 times 2 to the power j minus 1, j starting at 1 and ending at 5. Again, our table. So this is 3 times 2 to the power of 1 minus 1, which 1 minus 1 is 0, 2 to 0 is 1, 3 times 1 is 3. Replacing j with 2. Three minus 1 is 2, 2 squared is 4, times 3, 12. the sum, we add up these 5 values. 48 and 12 is 60, 93. Again, you can pause the video if you like and try the next ones on your own. This is the sum of -1 to the power of I starting at 1 and ending at 5. So I is 1, 2, 3, 4, 5. Now show the substitution. -1 to an odd power is going to be -1. -1 to an even power, +1. Now sum these up. E, we have the sum of 1 plus 2 times k minus 1. K going from 1 to 4. Substituting 1 in for k. It's going to be 0 times 2 is 0. And 2 in for k. It's 1 times 2 is 2. And continuing. Times 2 is 6, plus 1 is 7. And now the sum, 1 plus 3 plus 5 plus 7 is 16. And F, the summation of k times k plus 1 x, k going from 1 to 3. This is 1 times 2 times x is simply 2x. This is 2 times 3 times x, which is 6x. And then 3 times 3 plus 1 times x. 3 times 4 times x is 12x. And now, so this is equal to 2x plus 6x plus 12x, which is 20x. The 20x is the sum. Writing the addition of the terms is the series. This is a series. This is the sum. Exercise 2, which of the following represents the value of the summation of 1 over I going from 1 to 4? Alright, so try that on your own. Make your table. Okay, so we have three fractions here, and yes, you can use the calculator and add 1 plus a half plus a third plus a quarter. I'd rather write down equivalent fractions with a denominator of 12. All right, so 1 is equivalent to 12 twelfths, 1 half is equivalent to 6 twelfths, 1/3 is equivalent to 4 twelfths, and 1/4, 3 twelfths. And now if we add these, 12 and 6 is 18, plus 4 is 22, plus 3 is 25. So their sum, oops, is 25 twelfths. Exercise number 3 says, consider the sequence defined recursively by a sub n equals a sub n minus 1 plus 2 times a sub n minus 2. Let me stop there, okay? So if a sub n is our current term, a sub n minus 1 is the previous, the term before it, plus 2 times a sub n minus 2 is the pre-previous. So the current term equals the previous plus 2 times the pre-previous. And a sub 1 is 0 and a sub 2 is 1. Find the value of, we want the summation of a sub I going from 4 to 7. So in other words, we want the sum of the 4th, 5th, 6th, and 7th terms. We want the sum of the 4th, 5th, 6th, and 7th terms. Okay, so a sub 1 is 0 and a sub 2 is 1. So a sub 3 is going to be the previous, which is a sub 2, 1, plus the pre-previous. So that's 1 plus 0, which is 1. A sub 4 is the previous. Oh, I forgot to multiply by 2. Sorry, let me go back. Right. So the current term a sub 3 equals the previous, which is 1, plus 2 times the pre-previous, plus 2 times 0. 2 times 0 is 0, plus 1 is 1. Now the 4th term would equal the previous, 1, plus 2 times the pre-previous. This is 1 plus 2, which is 3. The 5th term would equal the previous 3, plus 2 times the pre-previous 1. And it's 3 plus 2, which is 5. The 6th term is equal to the previous 5, plus 2 times the term before 5, which is 3. That's 6 plus 5 is 11. And the 7th term is equal to the previous 11, plus 2 times the term before 11, which is 5. And it's 10 plus 11 is 21. So now the sum, we have 1. No, we want the sum of term the 4th to the 7th. So that is 3. What's these? We want 3 plus 5 plus 11 plus 21. 8, 29, 30, 40. It's good to be able to place sums into sigma notation. The values that are being summed in the next problems form either an arithmetic or geometric sequence. Look back at exercise number 1 on the previous page. Which problem represents some of the terms of an arithmetic sequence and which represents some of the terms of a geometric sequence? So, arithmetic sequence. Here we were adding 2 each time, right? So this would be arithmetic. there's no pattern here with B. With C, it looks like we are multiplying by 2, so C is geometric. D, let's see, I guess we could be multiplying by -1, so D is geometric. E, 1, 3, 5, we're adding 2, so E is arithmetic. And F, I don't see any pattern there. So A and E are arithmetic, and C and D are geometric. So arithmetic are A and E, and geometric C and D. So now we want to take, express each sum, which is also known as a series, in using sigma notation. Use n as our index variable. First, consider any patterns amongst the terms involved in the sum, then work to put these patterns into a formula. Okay, so in other words, if we look at these terms here, what do we do to 40 to get 28? What do we do to 28 to get 16? I think we're subtracting 12, right? Or we're adding a -12. So 40 minus 12 is 28. 28 minus 12 is 16. 16 minus 12 is 4. 4 minus 12 is -8. And then -8 minus 12 is -20. Okay, so this is definitely an arithmetic sequence. So a sub n equals a sub 1 plus n minus 1 times d. A sub 1 is 40. And d is -12. And make sure you put that in parentheses. So this is our expression. Right? Now, so this is the sum of n going from 1 to, well, what number term is -20? 40 is the first, 28 is the second, 16 is the third, 4 is the fourth, -8 is the fifth, -20 is the sixth term. So we end at 6. And 40 plus n minus 1 times -12. Now we can always check this on the calculator. If I go to y equals, put in 40 plus parentheses x minus 1, close parentheses, parentheses, -12. And now look at my table of values. So an input of 1, the output is 40. And the input of, let's try the last one we said with 6, all right, is -20. So we know that this expression is correct. You can simplify it. You don't have to. Just be aware that if it is a multiple choice question, oftentimes it would be simplified. In other words, you distribute the -12, and you get -12 and plus 12. And the positive 12 and 40 would be 52. So the sum of n going from 1 to 6, -12 and plus 52. Okay, B, 1/25 plus 1/5 plus 1 plus 5. Okay, so what's happening here is it looks like we are multiplying by 5. Right? 1/25 times 5 is 1/5. 1/5 times 5 is 1. 1 times 5 is 5. 5 times 5 is 25. So the next term would be 25. Go down here. And then 5 times 25 is 125. And then 5 times 125 is 625. Okay, so what number term is 625? Well, first, second, third, fourth, fifth, sixth, seventh. So 125 is the seventh term. We're multiplying, so this is definitely geometric. A sub n equals a sub 1 times r to the n minus 1. A sub 1 is 1/25, r is 5 to the n minus 1. So this is the sum of n going from 1 to 7, because the 625 was the seventh term. 1 to 7, and our expression is 1/25 times 5 to the n minus 1. And again, you can check that in y equals in the calculator. For C, what's the pattern happening here? -6 plus 3 would give us -3. -3 plus 3 would give us 0. So we're adding 3. We're adding 3 each time. So this is an arithmetic. A sub n equals a sub 1 plus n minus 1 times d. A sub 1 is -6, and d is 3. We just have to figure out what number term 15 is. So this is going to be the sum of n going from 1 to whatever number term 15 is, of -6 plus n minus 1 times 3. Alright, so let's see, use a different color. So -6, -3, 0, 3, add 3 would be 6, add 3 would be 9, add 3, 12, and then add 3 finally at 15. So 1, 2, 3, 4, 5, 6, 7, 8. So 15 is the 8th term. And D, what's the pattern here? -2 times -3 is +6. +6 times -3 is -18. Okay, so this is definitely geometric, because we're multiplying by -3. A sub n equals a sub 1 r to the n minus 1. A1 is -2. R is -3. And the only thing we need is what number term is this. So this is the sum of n going from 1 to, we'll figure out what number term that is in just a minute, -2 times -3 to the n minus 1. So I'll use the calculator to help. Since we have the expression, -2 times -3 raised to the x minus 1. Look at the table of values, and so just to check, yep, input of 1, the output is -2, and where do we have -1,458? Would be the seventh term. Okay, and we'll hold off on number 6. Thank you for your attention.